This is Geometry Semester 1. It's the 4th unit called Logical Arguments. It is the 3rd lesson called Two-Column Proofs Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents, with the notes for those pages from creatormath.com. So to show you that really quickly, let's run through an example here. So creatormath.weebly.com is how you're going to find the site. Type that into Google and hopefully you can find it. When you show up, it should be on the home page, which looks a little bit like this at present. This entire home page, if you just scroll down and see the words composition book and the picture composition book, everything under this is instructions on how to get that right. There's videos, there's instructions, there's deadlines, etc. Follow that. We're going to go straight to notes, which is under the geometry tab for geometry. All the videos, the practice sets, the notes, and vocabulary is under the geometry tab for geometry. So here is the vocabulary geometry practice study PDF. If you're not getting 100% on your practices for vocabulary for geometry, then you don't know how to open up this document and search it. Please figure it out. It's going to save you a lot of time and help you get your grade right and maybe even learn a little bit more. Okay. Let's go down to the table of contents. I'm actually looking for this video for semester 1. So just make sure you see semester 1. Table of contents. This should have all been written into pages 2 through 6 of your comp book. It's about 3.5 pages long, you guys. It's every line gets a line on pages 2 through 6. If you haven't done it yet, stop what you're doing now and go write that into pages 2 through 6 of your composition book. This is logical argument standard. This is a unit here. There's only 3 lessons on this, and this one is a very brief, high-level lesson on two-column proofs. It's on page 81 to 82, and don't take that for granted, but go back and look at the original table of contents when you're watching this video. Here are the notes, the problems, and the video solution will be linked here. We're going to click Notes and open this up. Sometimes it takes twice. Mine opened the first time here. You can enlarge it, and this is how you copy this onto your comp book. You're going to take, how do I present this? When I was in high school in geometry, we spent months on double column proofs, and logical reasoning. The entire curriculum has largely changed away from that. We do not spend months on it. In fact, we sort of give you an overview, and this is the overview on two-column proofs. We don't spend a lot of time. Do I lament those days? Yes. However, it's kind of what we've got given the time restraints that we're in. So this format here is a basic understanding of a setup of a double column proof format. There's a title, there's a graphic, it'll be a geometry graphic, there's a statement column, a reason column, and then there are rows or lines here that explain the different steps to the logical reasoning, and then at the bottom a conclusion. This format is what we're looking for in terms of understanding what is a double column proof. We'll look at a few basic ones. We'll look at a double column proof for vertical angles. So here we have, notice it fits the format. There's a title, vertical angle proof. Here's a graphic. There's a statement column here and a reason column here, and each of these run across in a row or a line. And at the bottom, conclusion, vertical angles are equal. So what does this proof do? This proof takes postulates, which are essentially definitions, ties them together into now what becomes a proof. So now we have for us a theorem. So a theorem is a proof based on postulates, which are definitions and basic common understandings. Definitions would be the simplest understanding of a postulate. A theorem is the building of those postulates into a proof that now we can present and use in geometry. So we use all the time that vertical angles are equal. This is a proof using postulates of why that's true. The vocabulary is, it's got statement and a reason, and let's look back at the format just for this one itself. And so if we have angle A plus angle B is 180, that would be a statement. And that is a rule for us. That's a definition. So those are called supplementary angles. So that goes in as the reason. We do it again, so A plus B, we have A plus B is 180, then we have B plus C is 180, right, supplemental angles. A plus B equals B plus C, so this has to equal this because they both equal 180. Then we can cancel out the two b's, right? So substitution, we substitute these for 180 here in this statement. Then we cancel out b's from both sides of the equation, and we have angle A equals angle C. So that those two are vertical angles from each other, and this proves that vertical angles are equal. Right? Subtraction property is we subtracted angle B from both sides of the equation, and they disappeared. So very brief, copy these notes into your comp book and go from there, double column proof, conclusion, and let's see what the problem sets are. They probably just reiterate what was covered in those notes. Given the following geometry proof format, what two aspects make up the double column characteristic? So this is called a double column proof. That's its name, right? Here's double column. Why? Because there's a column here, a statement column, and a column here, a reason column. And what is a column? I mean, I don't know if you can imagine a building. Can I draw a building? This is a building. Here's a doorway, and there's windows in it, right? Maybe we can draw a 3D building. Okay, so this is a building, and it's got windows in it. There are vertical elements to the building. The vertical elements are called columns. Columns, all right? And you learned that in a matrix, you have columns, which are up and down, and rows, which are side to side. We're also vertical and horizontal. We use the same, two dimensions over and over. We just call them different things. So these are called columns. You could call it vertical, statements of information, a statement here and a reason here in a vertical format. That's what a column is. So statement and reason are your two columns in a double column proof. Long explanation for sort of a basic idea of what it looks like. Given the following double column proof, what is the reason given for removing the b from each side of the equation? So right here in this line number 3, it's got a plus b equals b plus c, right? So we can subtract from both sides. If I say I'm going to subtract b from one side, from the left, and the side being the left and right of an equation, what I do to one side I must do to the other. B minus b is 0, gone, and also b minus b is 0, gone. What's left? An a, an equals, and a c. So the way we can do this is subtraction property, all right? And that's back in, it's right here also, it's actually in the proof, and it's back in the notes too. All right, given the following double column proof, what is the reason given for statement 3? All right, so here's statement 3. We know that because these are statements. Statement 1, 2, 3. It says angle 1 equals angle 5. Alternate interior angles. So notice angle 1 and angle 5 are here. If you did have a parallel line here and a parallel line here, which we do, this base and this, we can say that angle here and angle here are alternate interior angles, and therefore they are equal. So alternate interior angles, right, of parallel lines are equal. So that is they're being very gentle with us in this, this set of problems. They're giving us a statement and asking what's the reason. We're just looking and finding the reason and marking that and trying to deepen our understanding in a very gentle manner. All right, given the following double column proof, what is the reason for the given statement? 1. Here's statement 1, right? Statements 1. It says angle 1 plus angle 2 plus angle 3 is 180, question mark. So all they want is the reason, right? We're looking for the reason. I can see it right here. The sum of the angles of a triangle is 180. Let's just look a little closer. Angle 1 is here, angle 2 is here, angle 3 is here. So the sum of the angles of a triangle is 180 is, for us, a reason, statement reason is, that's just the reason given for this line, right? And that's all they're asking us. Let's go for this. In step 2, we could have said, nice, the sum of the angles of a triangle are 180. Okay, I'm marking that. All right, given the following double column proof, what is the reason given for statement 2? 1 equals 2. So statement 2 is here. Angle 1 equals angle 2. They're saying right here. I know why, because its vertical angles are equal. So now that we've proven vertical angles were equal in a prior problem, we can now use vertical angles are equal in later proofs, right? We can build proofs on top of proofs. So vertical angles, that's the reason why angle 1 equals angle 2. So with that very brief and light overview, This is follow the title, Geometry Semester 1. It's the 4th unit called Logical Arguments. It's the 3rd lesson called 2-Column Proofs Practice. It's on creatormath.com under the Geometry tab, and I hope that helps.